Energy, left to its own devices, dissipates. To persist in any environment, raw potential has to find a stable structure, a mechanism to contain and channel its own outward propagation. Legacy chemistry organizes matter through a static lens. The standard periodic table lists elements by mass and reactivity, presenting an inventory of substances as if they were isolated building blocks. This view captures the fact that certain chemical behaviors recur as atoms get heavier, but it fails to identify the underlying structural mechanics that generate those repeating patterns. The periodic table is a recurrent waveform. It is the visible projection of a 9-phase grammar of recursive closure. We call this cycle a nonave. It is a sequence of 9 immutable phase roles, required for any recursive system to achieve and maintain coherence. The elements occupy specific temporal addresses. They are stable configurations within a single, continuous structural cycle. This matrix charts the invariant structure of the traversal. It organizes the primary formative and containing dynamics of the universe through specific phase signatures like EEE, Phe, and Me. The top row forms the formative arc, mapping outward expansion. The bottom row forms the containing arc, mapping inward stabilization. They meet at the coherence anchor in the center. Familiar chemical families are simply downstream projections of these 9 specific grid addresses. Every element fulfills an operational role that remains consistent across increasing scales of atomic differentiation. The 2-dimensional periodic table is a flattened representation of this fractal 3x3 grid iterating over itself as the atoms get more complex. When we translate the matrix into a continuous oscillation, we can track how elements traverse these addresses over time. Address 1, the centrifugal spark, marks the initial ignition away from the axis. Hydrogen instantiates this role as primordial propagation potential. At address 2, we find the exploratory scaffold. This address is populated by the pnictogens, elements like nitrogen and phosphorus, that provide the directional framework for metabolic systems. These trivalent atoms exploit their lone electron pairs to build highly directional, informational non-covalent networks. They are suited for information-bearing structures rather than simple energy storage. The wave reaches its peak extension at address 3, the diffusive crest, before reaching the torque hinge at address 4. The halogens occupy this hinge. Their p5 valence shells create a structural urgency that forces the expanding wave to pivot aggressively back towards stability. This formative arc constitutes the system's differentiation phase, where it explores structural possibilities before seeking containment. At the center of the traversal sits address 5, the coherence anchor. This is the exact axis crossing point where the outward formative energy and inward containing pressure achieve impedance match. The noble gases are the anchors of the table. Their closed shells represent active phase inversion and dynamic stability. Under pressure, xenon and krypton form clathrate hydrates, encapsulating within water cages. The gas maintains its baseline stability within a field-mediated containing framework. The wave crosses the axis into the containing arc, moving through address 6, the focused indraw, and address 7, deep compression. The alkali metals at address 6 gather external gradients into biological rhythms. This selective extraction of pattern enables the neuronal firing driven by sodium-potassium pumps. The alkaline earth metals at address 7 provide the structural grounding. They form the doubly charged mineral building states that reach maximal inward density. This arc functions to stabilize and ground the patterns established during the formative arc. This leads to address 8, gestation saturation. This is the missing family of chemistry, never recognized as a coherent group because its elements appear scattered across unrelated legacy categories. This address contains boron, aluminum, scandium, yttrium, lanthanum, and actinium. They function as framework mediators and structural integrators. Boron acts as the primordial integrator. It scales localized 3-center bonds into massive polyhedral clusters, maximizing structural connectivity with minimum energetic currency. These elements must encode and carry forward the entirety of the prior traversal into the next substrate. Aluminum demonstrates this through passivating containment. Exposure to oxygen generates an amorphous oxide layer that encapsulates its massive reactive potential in an inert shell. Scandium precipitates maintain structural coherence through Zener pinning, physically blocking grain boundary migration within the lattice. As recursion depth increases, the coordination complexity of lanthanum and actinium scales to manage the increasing density of the traversal. This family functions as the structural gateway required to achieve a new emergence. The wave terminates at address 9, the centripetal surge. Here, convergent pressure ignites the next centrifugal spark. Carbon and silicon are respark elements. They simultaneously close one cycle and initiate the vast structural possibilities of the next. To stabilize this turn, the waveform requires mechanical hinge corridors. These are the D-block and F-block transition metals. As atomic complexity increases, the system requires more differentiation bandwidth to stabilize the traversal between gestation and respark. The elements from titanium to iron form a zone of compression toward ignition, while the nickel to germanium corridor represents post-ignition emergence. Relativistic effects in heavy elements represent literal phase drag upon the closure traversal. At extreme recursion, the containing field is so intense that the wave struggles to achieve the formative coupling necessary for a new spark. Transition elements provide the mechanical hinge that allows the recursive waveform to persist. This grammar is substrate independent. It is the generative architecture of electromagnetism, emerging as the first stable vector scalar closure of the cycle. The Maxwell operators occupy the exact phase roles of the matrix. Address 1 matches the outward differentiation of the electric field in Gauss's law. Address 4 matches the Ampere-Maxwell coupling of electric propagation to magnetic circulation. The coherence anchor sits at the phase change operator, the dynamic still point where field dynamics balance. Address 9 corresponds to the complete magnetic closure of Gauss's law for magnetism, providing the physical condition for a new spark. Catalysis is the localized facilitation of this traversal. Metal catalysts like rhodium provide stabilized recursive loops that route reactants into products without the metal losing its own structural integrity. The periodic table is what this electromagnetic grammar looks like when it achieves closure through atomic structure. This redefines entropy as incomplete phase closure. What is described as disorder is a traversal that has stalled before reaching its return. Glass science measures this through fictive temperature, a signature of trapped structural tension where the traversal has stalled. Persistence selects for closure. Systems that fail to complete their traversal either dissipate or rigidify. Living systems maintain themselves through the continuous execution of this 9-phase cycle. The families and transition corridors of the periodic table are all downstream expressions of this single generator. The elements do not behave as isolated entities. They instantiate recurrent phase roles across recursive depth. The recursion holds.